recording. And then we will start. And I remember last class, okay, let me admit. Last class, we discussed somewhere in the middle of note 6. So we will continue with note 6, okay. Note 6, so let me put a share screen. Okay, for note 6, for this cell, the local variable, non-local, global variable is pretty straightforward, okay? And so you can read it after class. And what the next part is also quite useful. And in Python, function can also be considered as object. That so you can also assign function to variable, okay, in Python. Then you can program very powerfully. Okay, so let's take a look. So anyway, there's a Fahrenheit to Kelvin conversion. Hold on, okay, I need to get someone admit. Oh, I need to stop this, admit, then re-annotation. So anyway, so this is a pretty straightforward, do some conversion, okay? And then this is a function name, is it? So you can assign function name to some variable, is it? And then you can kind of, you see, using the variable and plug in with value, is it? And because of this, we have another one. 2 people I need to admit. And because of this, then we can also then put the function in list, tuple, and dictionaries, like over here it shows, is it? You can also put the function as the dictionary's value. Then you see you have the key and you plug in with some arguments, is it? So that's what here means, this example. And then next, let's take a look at the next one. Also very useful. And I believe in some other programming languages, like in Java, you also learn Lambda, is it? Lambda expression right now quite used a lot, is it? And in Python, it also supports Lambda expression. Lambda expression is some small functions without name, anonymous little function without anonymous, the function no name, is it? So in Python, how do we define it? So the formatting is you have the keyword lambda. In some other programming language, you also have something like this arrow, is it? Or you call arrow function. The arrow function, or you just write like the arrow. So, but over here in Python, you need a specific with the keyword lambda. Following that is the parameter name, and then colon, and then the function body. Okay, that's how you define the lambda expression. Then in this case, it assigns this lambda expression, anyway, it's a function to a dictionary as a key value, okay? So that's, and also be careful here, it can only be applied to value part, okay? Because what? Because I need to admit, because key in dictionary, Python dictionary, is a key needed to be what? Immutable. And the function is mutable, is it? So you cannot assign it to key, okay? Okay, and then next, it's also regarding function, but here there's some, we call it a partial function, okay, in Python. So what does that mean? And we also see this recurring, okay? You will see it's quite powerful, okay, powerful. So anyway, so here's just a regular function, very straightforward, just a addition, is it? And if we want to use partial function, then you need to import it. Okay, you call from function to import partial. Okay, and then let's see over here. So then you call the partial parentheses. Is it the first parameter is what? Is the function name you just defined. Is it we just defined. And the second parameter is what? It's going to be part of the argument you're going to plug in for this function. But whenever, this is not a call function, because if you want to invoke a function, your argument needed to match the parameter, is it? But here, you just have a single argument, kind of, is it? But this phi is going to replace x. So basically, it's kind of, you get a new function. This new function is 5 plus y. Okay, so it's you from a very general add a number, then you get a new function, kind of works as 5 plus any number. Is it? So that's called a partial function. And then you can just call this using add 5. You plug in 3, then this 3 will match the second parameter. Okay, so this is a concept of partial function. We also call it curring. And next, let's see curring function. Okay, very interesting. Let's see. So curring function. So it's said it's an easy way to get generalized function from more general functions. Okay, so let's take a look here. You define some function. It has a 1 parameter. Then within it, did you see? Then you define another function. Then you define another function. Is it? This is kind of weird, is it? Because within a function, you define some other function. We never saw this, is it? It's not like a recursive function, it's call it itself. But here you define another function with some outer function. So the second one, the inner one is called line. The third one is compute, is it? So what does that mean? Oh, okay, over here, X is list, is it? You generate some range of numbers, is it? And you get to the number. And then here we call simple function, is it? You call simple function. And with this simple function, you plug in with 3. And then how about the inner one, line and compute, those two? How do we access that? Is it? So you can access, did you see? Because once you do this part, that matches the top level. And then this matches the second level. And the last one going to match the innermost level. Okay, so this is called a curring function. Curring function. So with a more general one, is it? So basically over here, that's the only function body. Function body. Is it? But you see, for the function body, you have parameter A, parameter B, and then you also have this parameter 3. Is it 3 parameters? This is the body. But you see, we can kind of decompose it to multiple levels. Then you kind of level by level through the, we can kind of single argument. And anyone can turn off the audio? Turn off your audio? Okay, so this concept is called curring function. Okay, so then let's see the result. Is it for the first one? Is it you plug in 3? The second one, you leave it empty. The third one is this list. Is it? So the 3 going to match A. And the second one, there is nothing plugged in. So it will go with this default value 0, is it? And the third one will take this sequence of numbers, is it? And then for the next one, it's called plug in A with 3, and B this time is -2. And X array, then it matches with this sequence of number. Okay, so this is a curring function. And let's take a look more example. Okay, let's take a look at the last one. So over here for this curring function. So you have F, then you have G, then you have H. The last one, you have 3 parameters, but the first 2, we only have single parameter. And then when you invoke it, is it? Then you can do something like this. So this just said, okay, if you have a function that has multiple parameter, but sometimes you may want to use that function to form some specialized function, is it? Based on part of that function, then you can do this kind of concept called curring. Okay, you can decompose it into multiple levels. Okay, multiple level of function. Then when you call, is it? You can plug in the corresponding value, is it? So that's a concept of curring function. And then what is the next one is also very important concept called generator function. Generator function, okay. And generally speaking, so far we learned of the function, you only have some single return point. As in once you have that return, that function terminates, is it? So is there some, but you see, whenever you do so, assuming you do a loop, is it? Then there is no way kind of you can record each intermediate level of course value, unless you use some collection, like some list or some array, is it, to record all of the intermediate values. Otherwise, there is no way to return, because once the inside function you call return, it finishes, is it? The function completes. But in Python, it's not that case. There is a special way you can deal with it. It's called generator, okay? Generator. So within the generator, you use a special word, yield, not return, okay? You cannot use return, use yield. So let's take a look at this function, define, okay, initialize, then you do a loop, is it? And basically within the loop, so X is keep increment by 1, is it? But what your hope is, I want to record, to log all values of X. So it's a sequence. Is it a sequence of numbers? But if you take a look in this example, we didn't use a list, is it? Otherwise, you need to have some list, is it? So like L equals something, is it? And then you can do append. Then you return that list, is it? That's not the way here we are going to do. Here it uses a special word called yield X. Then each time, like X, when X is 0, it will be logged somewhere. When X 1, it will also be logged somewhere. Okay, so this kind of function, we call it a generator function. Okay, generator function. And if you take a look, like here we call for, what it will give you is as a generator object for. It just tells you where it is. If you do want to get, because this yield will generate a sequence of items, is it? But this sequence of items, it's not recorded. Not recorded in a collection ADT? Is it not? Okay, so this function kind of has some mechanism to hold all of the sequence of numbers, the function itself. Is it? Because of this special word yield. Is it? So if you do want to get all of the number, we do this asterisk. You can do the asterisk. Okay, so who remembers what the asterisk here performs? Previously, we learned the asterisk, one of the usage in this quiz, in this scenario, it's a sequence of something. Is it? And then you do the asterisk. So what does it do? This asterisk. Who still remembers? So how about this is going to be the first quiz question. Anyone knows? Anyone still remembers what this asterisk do over here? Because anyway, this returns some sequence of something. Is it a sequence of numbers? 0, 1, 2, 3, some sequence. It's not a list, not a tuple. Is it? It's some sequence of something. Is it? And because sequence of something, you can use asterisk to get all of it. What do we call that? Anyone still remembers? There are some.
Maybe use
please. What?
It's used for arguments and multiple arguments.
Yeah. And what does this do here? We have some word, special word.
Unpacking.
Yeah, very good. It's called unpacking. Yeah. Yeah, it's unpacking. Okay, so remember this, unpacking. Okay, so yeah, you can send your answer to our chat. So this is the first quiz question. And basically the generator function serves kind of like, so we can view it returns an iterator. It returns an iterator, okay? So basically, if you assign for to ITR, to some variable, ITR, this is a variable, is it? And then you can always call next to get the next item. Is it? That's iterator we learned before. Is it the next? So it's kind of returns an iterator, okay? And because it's an iterator, you can also use it in a for-in loop, okay, for-in loop. So that's regarding generator function. Okay, then next, let's see, there is another concept called generator expression. So let's take a look over here. So this is a variable, then we have parentheses, is it? And here you have some loop, is it? And here, this is a variable, it does something. This is an expression, and then you have for-in loop. For loop. And generally speaking, you can also do some condition. Is it if condition? Is it? And the last class, what we learned is you can do something with a square bracket. Is it? What does that call? Who still remember? That's a second quiz question. What does that call? Expression, some for loop, and some if condition or some condition. What does that call? If you do something like that. Who still remember? If you use square brackets. That's called what? List comprehension, is it? Okay, so that's list comprehension we already learned. So it's generate a list of items, is it? Okay, over here, if you take a look, so here we have the loop, is it? And some expression. This is some expression, is it? And instead of square bracket, we have curly bracket. So this is called a generator. You can write as generator function, okay? So this basically is also a generator, but just in a single statement. So this is called generator expression. So because it's a generator, so what does it mean? So you can either use it using next to get item by item, is it? Or you use it in the for in loop. Is it for in loop? So here, if we want to get every single value in this sequence of number, then you use a for loop. Is it? And what next try to show is, of course, because here it's some sequence of something, is it? And of course, you can do some operation on it. So here you do summation of the sequence of items, is it? Next, what it also try to show is this is going to be what? So this is a generator, is it? And then you do what? You generate a tuple, is it? Generate tuple. And then you apply it to what? To a dictionary, is it? So there are, you can see it's very powerful, is it? If you want to apply some generate a sequence of items, so here is another way you can use also generator expression, okay? So we learned two new concepts, generator function. It has a special keyword, yield, and the generator. These two are related, okay, generated expression. So it's just a simple version of generator function. Okay, that's regarding generator. And underscore. In Python, there are a lot of usage, okay? I'm not going to go over all of them, okay? Just pick some of them to cover. So one is if you do something, you say A plus B, then you do underscore times C. What does that mean? So this just means you take whatever previous thing, is that expression, and then you times 3. So it's A plus B, A is 20. So it's 30 plus times 3, you get 90. Is it? So that's one way to use it. And here, is it? Over here, it's just kind of like some variable. Okay, just something like variable. Okay, then it will take, and we already learned the asterisk is for unpacking. And over here, it's similar. It's like some variable, okay, underscore. And it can also be used for separating digits. Okay, there are digits. So that's, and later on we will learn how to create a Java class. Okay, so we will come back at that time to explain the idea. But maybe let me briefly explain. So for the underscore, there is another thing here. So here you have the underscore ahead of, is it? So kind of like a prefix underscore, is it? Under a variable name. So variable name, is it? A single one. And sometimes you have two leading and variable name, is it? And sometimes you also have some variable name. So post kind of, is it? And you can also have double. And here, this is a function. Is it Python function? So Python function init, and it has two leading underscore and two tailing underscore. Is it? So what are all of this means, okay? So basically in this case, so this is considered as, so in class, later on we will say that whenever you define a class, it has some instance variable. So this is considered as instance variable. But instance variable, they have visibility. In other language, we learn 3 types of visibility. Is it public, protected, and private? Is it? But Python is not object-oriented programming language, is it? So it doesn't have very strict visibility difference, okay? But it can still achieve certain level, okay, visibility, kind of like public, protected, and private, okay? Like then in this case, this name, then it's a public kind of. This, if you have this underscore and this kind of, what it means is only visible within the module. Within a module you define, a Python module, okay? So you can kind of understand it later when we learn inheritance. It's kind of like protected, okay, but not strictly, okay, because it's within module, okay, within module. And if I do something like this, self dot double double number equals 9, then this is private. Okay, visibility. Okay, so that's the difference, okay. So later on we will see class example, we will have better understand. And the post underscore. So class, we already know it's a Python keyword. There's sometimes if you use a Python keyword as a variable, then you can put a underscore, post underscore, trailing underscore, okay? They took avoid the confusion. And next, let's see. So over here, oh, we already explained. So this is two leading, so double leading underscore. Okay, I had a variable, then it's private. Is it like over here it shows? So this object, it's an object of this my class, is it? Then you cannot directly access. So if you want to object dot underscore underscore variable, you will have the arrow called no attribute, okay? But in Python, so that's why we say Python is not a very strictly visibility defined, okay? But you can still use a way, in Python, we call it mangling. Okay, name mangling. Then you can still access it. So how that work? So you have this object, then has the leading underscore, the class name. And following that, you will have this two leading underscore, and then that variable. In this case, then you can access it, okay, outside of the class. So even though it's definitely defined as private kind of, is it? Okay, so that's regarding that case, we just see. So private means you see, then this leading underscore variable, so it's also accessible in some other function, not just initial, okay? So it's not a local variable, okay? This is not a local variable, okay? Because it's instance variable, okay? So next, let's see. So it's still class, is it? And for this class, if you take a look, if you recall, in Python, we have that string function, is it? And here you can also kind of override the string function. Then you can do leading double underscore and trailing underscore. Okay, so then what this will override the Python itself's string function for any object. Okay, for any object. So what over here is, later on we will also learn this. This is some new thing, okay, called literal string interpolation something, okay. So it's after Python 3.0, okay. Anyway, so this is a string, okay, this is a string. And it's for formatting, for string formatting, okay, string formatting. And what over here it does is it's override the string method itself. Is it? So it's going to define, okay, it's going to format the output something like this, okay, something like this. And then let's see, generally speaking for the string method, is it? So in Python, you can do print, is it? Generally speaking, you can print within it. It can be like a primitive data type. Is it primitive data, or you call scalar? Is it data? And the string, of course, it works, but in Python we just use str. Is it string type? But this is not a string, is it? My class is some user-defined object, is it? So this object is a user-defined object. And if you want to do print, it will call the default string method. This is kind of like Java's toString method, is it? But over here, you just do print object. That's it. If you take a look at the output, you see the output following this format, it's defined. Is it? So that means you didn't do obj.str. You didn't do that, is it? But you just call object, but it basically will call this string method. Okay, string method. Okay, so that's the underscore. Okay, the next thing is also quite useful. It's called decorator. Okay, Python decorator. Okay, decorator. So it's also kind of something. So decorator is involved with design pattern in Python. Okay, design pattern is also a big topic. Okay, in programming, in software design. Okay, that decorator basically it says dynamic alter the functionality of a function. Okay, of a function. So you can basically, why we call decorator. So you want to do some special thing. You say you want to do some decorating, is it? And in Python, decorators that has some use cases. And if you do some web programming, Python framework is as Flask, a Flask or Django, is it? Yeah, so here, let's see what a decorator means. Let's take a look at example, okay? The concept maybe at first it's not quite easy to understand. If you take a look at this function first, this is a very general function, as it just define some parameter and just try to print out the parameter. Same thing, is it? But over here, this is kind of annotation as an at and decorate. So what that is, this at decorate, if you take a look in this module, we define the decorate. This is a function, but this function is a parameter is a function. Function as a parameter. Okay, and then within it, if you recall previously, we learned curring function. But this is not a curring function, okay? So within this decorate, you define a function called wrapper function. Okay, wrapper function. What this wrapper function does, it's return this function. Return whatever you plugged in as parameter, that function. And overall, then the inner level defined function wrapper function, here then it's going to be returned. Okay, returned. So, okay, hold on, let me admit. Okay, so just be careful. Okay, so we have one level, outer level of a function and the inner level of the function. The outer level of function return what? Return inner level function. And inner level function return what? Return the function, the parameter, whatever function plugged in, it returns a function. Then over here, it does something. Okay, does something. So what over here try to do, okay, so there's a function and this belongs to whatever the function's attributes. Okay, it's called underscore name, okay? And you just try to get to the function name, okay? Okay, we understand this. Then let's take a look over here. Okay, so then over here, you have that annotation decorate. So that means you decorate this function with this decorating function. Okay, this decorator, okay? And same thing, function 2, then you're going to decorate. And who is going to be plugged in with this decorate? Then over here, if you take a look, here is you invoke the function. First you invoke my function, plug in with a hello. So what is going to work is, because this is decorated, this is decorated. So it's kind of, it's go to here first to start execution. Call the decorating function and plug in with what? With my function. So it's going to plug in with my function. So that's why the output is going to say, oh, in decorating function. So you have this output, And then it goes to what? That's a wrapper around your function, the plug-in function, So it will give you the name, It will give you the name, executing the function, the function's name, The function name, if you take a look, what is it? It's execution, the function. Execution, the function? And because for this function, whatever you plug in, whatever you plug in, it's also going to print its parameter, Print the parameter, whatever we plug in with that hello, So that's why the hello is also going to be executed, The print hello. So it first execution this part. This is within the decoration, not a part of my function. You try to decorate, you try to add more thing. Add more thing. Okay, and then it's called this print. And then you also invoke function 2. Then same thing, function 2 is going to be, oh, it's called my function 2, Yeah, my function 2 is going to be plugged in here, So it's going to output its name. And over here it says executing function 2, is it? And then it's execute function 2, what it actually is print, welcome, and the word, is it? So this is a concept called decorator. Okay, decorators. Okay, decorator. So here I'm trying to think how to understand the decorator. So each of this function is do something, some task. Is it suppose you build a house or you build a car, okay? Or you build a boat, you build an airplane. Anyway, you build something. And this special decorating function, we can kind of understand it's doing some decorating work. Suppose we call it a paint. Is it the paint work? Okay, so this is a painting, suppose a painting contractor. Is it? So it can do all sorts of painting for house or for car or for airplane. Is it? Then depends on you build a house or you build a car or you build a plane. Is it? It's going to paint either on house or on car or on airplane. Is it? So it's depends on your task. Is it? But it's all going to do the painting. So it adds on a feature for your build a house or build a car. So that's why we call it decorating, okay? Okay, so this is one example of decorating. So let's take a look more example to better understand it, okay? So here we have this great function. Then in this case, did you see it decorate with another function called uppercase? So what this function does anyway, so this whatever function it returns is going to be recorded in a local variable, okay? And then it's called the upper. Okay, so it's convert of the letters to uppercase, and then it return it. Is it? And if you call this grade, did you see what you get? You get all uppercase. Is it? So here is another. Let's take a look at this example. More. You can also decorate with more decorate, not a single, multiple decorators. Okay, so here, great, same thing. And here we have one decorate we call strong, the second decorator called emphasize. For the strong, what you do is this is whatever return. Then you add some label, is it? And for the second, you add some label, is it? And did you see if you call this grade, it's going to invoke the decoration, is it the decorator? So did you see it adds those labels, is it? So you can see kind of this is going to be quite helpful if you do web programming, is it, or mobile programming, is it, with scripting, okay? So it's that's why we call them decorating, okay? So quite helpful. So let's take last example about the decorating. This is, it may look kind of comprehensive. You have this say function. It decorated with some trees function. Okay, decorator. Okay, so this trees, it defines some inner ones, is it? So what it does, just some print, is it? And we can do formatted print using curly bracket 0, 1, 2, is it? And then after, within the format, then you plug in with the corresponding variables, is it? So here we have another way to, it's more simple, okay? We call it literal string interpolation. Okay, so it's within so it can also be applied to a string. So you have this F, this represent formatted, and whatever string is it, and within it, whatever the variable, the dynamic change once, don't use 0, 1, 2, 3 anymore. You directly plug in the variable name. Okay, like here, args and the keyword args. You directly plug in. Okay, but with F, then this two has the same effects. Okay, same effect. But anyway, so over here, what it try to do is it's just give some output, is it for tracing purpose, is it of the function call. And this C function that's going to be decorated by this decorator. Okay, decorator. So that's what this example shows. Okay, the last one for note 6 is regarding iteration tools, iter tools. Okay, iter tools, there is a very useful function related with it called group by. Okay, but later on when we learn pandas, we will also see group by, huge usage in data analysis. Okay, so if you want to use iter tool, you need to import it. Okay, so anyway, this is a lambda expression. Okay, so the group by for the iter tools, what it does is this is some collection, and you specify the group by key. Okay, group by key. So in this case, you're going to use the first letter. Is it the first letter to do the group by? Okay, to do the group by. And what it returns, okay, what it returns, the first is what? Is the key. And the second following with it is what? It's some tuples. Okay, second element of the tuple is another iterator. Okay, is another iterator here. Okay, and so let's see, the names over here is a list of words. Is it? You want to group by the first letter. So that means under A, whoever the word is, you want to go with A. Is it? And whatever B will go with B, whatever W, that will go to W. Is it? So how do we do this efficiently? You can use iter tools group by method. Okay, and the first one is some sequence, and then you specify the key is by what specification you're going to do the group by. Okay, so here it says, okay, I'm going to just take whatever the first letter. Okay, you use some lambda expression to achieve this goal. So basically, that's all of the information today.